So today in this video we are going to discuss about an instrument Venturimeter, which is used to measure discharge through pipe. Okay, so here a pipe section is drawn and within that pipe section a Venturimeter is connected. Now this Venturimeter consists of three parts. The first part is a converging section, the second part is throat, and the third one is divergent section or diverging section. And this Venturimeter is connected with a differential U-tube manometer. Now left limb of the differential U-tube manometer is connected at the inlet of Venturimeter, while the right limb is connected to the throat. And mercury is also filled in the U-tube differential manometer, and the other fluid or the liquid which is there in this is water. And this differential U-tube manometer is attached with a graduated scale. Okay, so now we know that the equation which is used to calculate the theoretical discharge through Venturimeter is A1 A2 under root of 2 GH upon under root of A1 square minus A2 square. If you want to see the detailed derivation of this equation, then it is there in my playlist, so you can watch it, that how we can derive this equation from basics of Bernoulli's theorem, which works on the principle of law of conservation of energy. Okay, so now if you look at this equation, here A1 and A2 are the cross sectional areas at the inlet and at the throat of the Venturimeter. So if D1 and D2, so if the values of D1 and D2 are known to you, then you can calculate the values of A1 and A2. Here 2 is the constant, G is gravitational acceleration whose value is 9.81, and H is the pressure head difference that will be obtained using U-tube differential manometer. So as we have discussed in previous video, that the pressure drop or the pressure difference will take place when your fluid will move from the inlet to the throat of Venturimeter, because its cross sectional area is changing or it is decreasing. So here at this section, as the cross sectional area is more as compared to the cross sectional area at throat, the velocity will be less and the pressure will be higher. And as the fluid moves towards the throat, the cross sectional area will decrease, resulting in increasing velocity and decreasing pressure. So that pressure difference between the section 1 and 2 or between the cross sectional area A1 and A2 could be computed using this U-tube differential manometer, and that is computed in terms of the value of head H. Okay, so that will be the value of H that you will obtain through this U-tube differential manometer. And again A1 and A2 are the cross sectional areas at the inlet and the throat of the Venturimeter. So in this way you can calculate the theoretical discharge through Venturimeter. But now if you have seen, then in your books a coefficient of discharge is used. So whenever you want to calculate the actual discharge, then you can use this formula where CD is the coefficient of discharge and Q theoretical is this value. So now my equation will become CD into A1 A2 under root of 2 GH upon under root of A1 square minus A2 square. Okay, so when we want to calculate the actual discharge, we need to multiply the coefficient of discharge, because see students, when we are calculating theoretical discharge, the fluid will be considered will be ideal. So in case of ideal conditions, the head loss will not be there. Okay, but same when we are considering real fluid, that when we want to measure the actual discharge in field, the fluid which will be used will be real fluid. So in case of real fluid, viscosity will be there, head loss will be there, as the friction will be there. Okay, so in that case we need to multiply the coefficient of discharge CD with the theoretical discharge value to get the actual discharge. Okay, and the value of CD which is used for Venturimeter is 0.98. So in this way you can calculate the discharge through Venturimeter, which works on the principle of Bernoulli's theorem. Thank you.